Hello friends, welcome to my channel. In this video, I am discussing about external division. The external division of a line it somehow looks like this, where P lies outside of the line AB, where ABP and PAP. I can read. P divides AB as AP divided by BP. P divides AB as AP divided by BP. Similarly, in the next case, P divides AB as AP divided by PB. When number 1 AP divided by BP is less than 1, that means AP is less than BP. It follows the second case, AP is less than BP. Secondly, AP divided by PP is greater than 1, where AP is greater than BP. This follows the first case, AP is greater than BP. Now let's derive the formula for the external division. Let P divides the line AB into M is to N ratio. That means we can write AP divided by BP is equal to M divided by N, that gives rise to AB plus BP by or divided by BP. We can get AB plus BP by splitting out the AP. As you can see, AP can be split out in AP plus BP. Now, AB plus BP divided by BP gives rise to AB divided by BP plus 1 is equal to M divided by M. Taking this 1 into the side of M divided by N, I can get AB divided by BP is equal to M divided by N minus 1. That gives rise to AB divided by BP is equal to M minus N divided by N. Writing this into coordinate system, I can get AB divided by BP as x2 minus x1 divided by xp minus x2. Let me show you. AB can be written as x2 minus x1. BP can be written as xp minus x2 for x point. Here we are deriving the xp point of P. So I have taken all the x coordinate of the A and B. Now by cross multiplication we can get n multiplied by x2 minus x1 is equal to m minus n multiplied by xp minus x2. By multiplying n into each term of the x2 minus x1 and m minus n to each term of xp minus x2, I can get nx2 minus nx1 is equal to m minus nxp minus m minus n x2. By taking outside or taking one side to all x2 term, I can get nx2 plus m minus nx2 is equal to m minus nxp plus nx1. By taking common x2 outside, I can get x2 multiplied by n plus m minus n is equal to m minus nxp plus nx1. That gives rise to x2 is equal to m minus nxp plus nx1 divided by m. From this equation, we can get xp point as mx2 minus nx1 divided by m minus n, which is the formula for derivation of xp coordinate of point P. Now, following this similar procedure, we can find yp. Taking AB divided by BP is equal to y2 minus y1 divided by yp minus y2, which will give the formula yp is equal to my2 minus ny1 divided by m minus n, which is the y coordinate for the point P. Using this formula, we can find the P coordinate that divides the AB line externally. Now let's discuss about the distance formula of straight line. Distance formula of straight line says that we have to derive the distance between 2 points situated in the plane. As you can see, I have drawn the xy Cartesian plane on which I have placed 2 points named P1 and P2 having coordinate x1, y1 and x2, y2. If I draw perpendicular from the points P1 and P2 of respective coordinates to the of respective coordinate to their respective axis. Then I get a diagram like this. That is, I am drawing a line perpendicular from x1 coordinate to the x-axis, similarly perpendicular to the y1 coordinate to the y-axis, and x2 coordinate drawing perpendicular from x2 coordinate to the x-axis and perpendicular y2 coordinate to the y-axis. On drawing this formula, I can get a right angle triangle on this common region of the diagram. So by applying Pythagoras theorem, we can get the hypotenuse that denote the distance between P1 and P2. We can write h square is equal to p square plus p square, where h is the hypotenuse of this triangle. So h is represented by the line P to P1. So I have written here P to P1 line whole square is equal to p square, or the perpendicular is represented EP1. Perpendicular is EP1. So I have written here EP1 line whole square plus the base EP2. EP2. So this formula can be converted for the triangle as P to P1 line whole square is equal to EP2 line whole square plus EP1 line whole square. Now writing this into coordinate system, I can get P to P1 whole square is equal EP2. EP2 gives me x2 minus x1. x2 minus x1 whole square plus for EP1 I can write y2 minus y1 whole square. So we have derived by using Pythagoras theorem the line or the hypotenuse of the triangle which represent the distance between these 2 points P1 and P2 as root over of x2 minus x1 whole square plus y2 minus y1 whole square. So by using this formula we can derive the distance